Lesson 2-4B, Proportional Relationships. These can be represented different ways. The first is in a table. If you take the y values in a table and divide by the x values, you would get the same value every time. The second type is an equation. You could see proportional relationships in an equation. The equation will always be in this form: y equal a number, we call it k, times x, where k is a number. The third way we can see a proportional relationship is in a graph. There are two things we look for in a graph. We look to see if it is a straight line and that it goes through the origin. It goes through 0, 0. The last way we might see a proportional relationship represented is in a situation. In a situation, it will start at 0. It'll have some kind of starting point that is 0, and it changes at a constant rate. So we have these 4 different ways that a proportional relationship can be represented: a table, an equation, a graph, or in a situation. Determine if each representation is proportional. We'll refer back to our types of proportional representations above in your notes. In our first example, we have a table. We've got the ordered pairs 0, 0, 1, 2, 2, 4, and 3, 6. And remember in our information above that you've written down that in a table, if y divided by x is the same for every ordered pair, then it is proportional. So I'm going to figure out what y divided by x is for every ordered pair. We'll start with 0 divided by 0. Can we do that? No, we can't divide by 0, so we're just going to skip that one. And then we can say 2 divided by 1, which is 2. We have this ordered pair, 4 divided by 2, which is 2. Then our last ordered pair, 6 divided by 3, which is 2. So y divided by x was 2 every time except the first one, which was 0, 0. Now I do want you to notice this, however. 0, 0 is the origin if we were to plot this as an ordered pair in a coordinate plane. And so it does go through the origin, and we've got y divided by x is the same for every one of these. So yes, this is proportional. Okay, for B part, we have an equation. It is written as y equal 1/2 x, and you'll notice that we want to compare it and see if it's in the form of y equal k, a number, times x, and it is. K is just a number, k is 1/2, so it is in that form. It is proportional, so we would say yes. Now we have another equation, y equal x plus 1. We want it in the form of y equal k times x. Well, the number in front of the number in front of x would be an invisible 1, and we do have that, but this plus 1 on the end makes it not work. It doesn't have a plus 1 here, so that does not work. This is not a proportional relationship. Okay, our next representation is a graph, and we look for 2 things. Is it a straight line? Yes. Does it go through the origin, as in it goes through 0, 0? Yes. So is this a proportional relationship? Yes. E part is a situation. Eric has $50 in his savings account and adds $20 per week. So in a situation, we look to see if it starts at 0, and does it have the same rate of change? Does it change at same rate or constant rate? So he has $50 in his savings account. So he does not start at 0. He starts at 50. So right there we can say no. He adds $20 per week. So it is changing at the same rate. It's going up $20 every week in his savings account. But since he did not start at 0, this was not a proportional relationship. Part F is another situation. Lupe reads 57 pages per hour. Let's see. Does she start at 0? If it doesn't say so, then we can assume that yes, she must have started at the beginning of a book. She starts at 0 pages, so yes. And is it a constant rate? It just says she reads 57 pages per hour, so that means each hour she reads 57 pages. It is the same every time. So yes. So is this a proportional relationship? Yes.